In this section, we'll summarize what has been covered in this chapter. Time planning is one of the most important processes performed during your project. The specific planning activities include activity definition, activity sequencing, activity resource estimating, activity duration estimating, and schedule development. The activity definition process involves decomposing the work packages into schedule activities that can be easily managed and estimated. Output from this process is the activity list, activity attributes, the milestone list, and requested changes. The activity sequencing process takes activities and puts them into a logical order based on dependencies. Dependencies are determined when one activity relies on a preceding activity to finish in order to begin. There are three types of dependencies: mandatory, discretionary, and external. The network diagram shows how the project tasks will proceed from beginning to end. Using the estimates from each task, the network diagram provides the best estimate of how long the project should take to complete. There are two ways to draw network diagrams: activity on arrow, or AOA, or activity on node, AON. Activity on node is also known as the precedence diagramming method, or PDM. In this method, boxes are used to denote activities and arrows show task dependencies. This method adds leads and lags to the relationship between tasks, and this method does not use dummies. In the AON diagram, there are four types of relationships between tasks: finish to start, where a task must finish before the next one can start; finish to finish, start to start, or start to finish. In the activity on arrow, AOA, activity on line, or arrow diagramming method, ADM, the arrows are used to represent tasks. The boxes represent task dependencies. Only finish to start relationships are used between tasks, and it may use dummy activities represented by a dotted line and inserted to show dependencies between tasks. No work is represented and no time is allocated for dummy activities. Estimating methods include critical path method, CPM, program evaluation and review technique, PERT, and Monte Carlo. The critical path method is not to be confused with finding the critical path. It refers to estimating based on one time estimate per activity, and it emphasizes controlling cost and leaving the schedule flexible. It also uses dummies. PERT has three estimates per activity: optimistic, most likely, and pessimistic. This is called the three-point estimate. It can be used to estimate both time or cost, and it emphasizes meeting schedules or flexibility on costs, and it uses dummies. You need to memorize these formulas for the exam. The PERT formula is the sum total of pessimistic estimate plus 4 times the most likely estimate plus the optimistic estimate, all divided by 6. The standard deviation of a task using PERT is the pessimistic estimate minus the optimistic estimate, the sum total of that divided by 6. And the variance of a task using PERT is the sum total of pessimistic minus optimistic divided by 6 and brought to the second power. The Monte Carlo simulation of estimating uses a computer to simulate the outcome of a project based on PERT estimates and the network diagram. It provides probabilities for completing the project on any specific day, completing the project for any specific amount of cost, of any task actually being on the critical path, and the overall project risk. The critical path is the longest duration path through a network diagram and determines the shortest time to complete the project. Any path with the longest duration is the critical path, and there's no slack in the critical path tasks. Lag time is inserted waiting time between tasks. Slack, or float, is the amount of time a task can be delayed without delaying the project. There's 3 types also. There's free slack, which is the amount of time a task can be delayed without delaying the early start date of its successor. The total slack, which is the amount of time a task can be delayed without delaying the project completion date. And project slack, which is the amount of time a project can be delayed without delaying the externally imposed project completion date, which has been required by the customer or management. The activity resource estimating process determines the type and quantity of resources needed for each activity. Duration estimates are then produced in the activity duration estimating process. Analogous estimating, also known as top-down estimating, can be used for estimating the schedule or cost. Parametric estimating takes the time measurement for one unit and multiplies it by the number of all units needed to get the estimated time or cost. The 3-point estimates take the optimistic, most likely, and pessimistic estimates and average them for a time-cost estimate. Reserve analysis takes schedule risk and adds a percentage of time for contingency. Schedule development is the process where a start and end date are assigned to each activity. Schedules may need compression to meet dates. Crashing looks at cost and schedule trade-offs. Fast tracking involves performing tasks in parallel that were originally performed sequentially. Schedules are typically depicted in graphical form using Gantt charts, milestone charts, or project schedule network diagrams. This concludes the summary for Chapter 7. In the next section, we'll go over points that are important for the exam.